Stop worrying about homework and start learning with confidence. This is Ask Learn. Complete help for every subject. Like, share, subscribe for daily learning videos.
Hello. This problem deals with a charged particle moving through a uniform magnetic field, and we just need to know our knowledge of magnetic forces on moving charges and a little bit of Newton's laws to figure out the relative direction between the velocity of this charged particle and the magnetic field. So just drawing a diagram of what's happening, we have, we'll just say our magnetic fields are heading to the right like this. And it tells us that the direction between the magnetic field and the velocity is less than 90 degrees. So it might look something like this, where we have our charged electron here. We'll put a little negative E there for the description of the charge. And we could say maybe it's heading like up in this direction, because then the angle between this velocity direction here and the magnetic field direction, let me write my B vector here, is going to be less than 90. And so we just want to find that angle theta. But we remember from the textbook that the magnitude of the magnetic force being felt by this charged particle is going to be equal to the absolute value of the charge of the particle, the velocity of the particle, the magnitude of the magnetic field through which the particle is traveling, and sine of the angle between the magnetic field and the velocity. And that's the thing that we want to find, that theta. We are also told that this is the only force acting on this electron. That means that this force can be completely made up. Actually, this force completely makes up then the net force acting on our object. And then if we know this is the net force, then that's going to also be equal to the mass of our electron times its acceleration. And we're actually given information about the acceleration of the object instead of the force on the object. So we'll want to use that. But we've been given everything else. We know the charge of an electron, we know its speed, we know the magnitude of the magnetic field, and we know the acceleration of the electron. And we can also look up its mass from the internet. So in the end, we just need to set these two things equal to each other and solve. So we have Q naught VB sine theta is equal to ME times A. So solving for theta, we see that it's the inverse sine of a big thing here. We have the mass of the electron times its acceleration divided by the charge of the electron times its velocity multiplied by the magnitude of the magnetic field. So let's plug all these things in. What is the mass of an electron? It is 9.1 times 10 to the negative 31 kilograms, very tiny, multiplied by, let's see, its speed is given, or its acceleration, sorry, is given as 3.50 times 10 to the 14 meters per second squared, so quite large. This electron is being accelerated quickly. We got to divide that by our absolute value of the elementary charge, 1.6 times 10 to the negative 19 coulombs. Multiply that by the velocity speed given, which is 6.8 times 10 to the 6 meters per second. And then the value of the magnetic field, I'm going to squeeze this in here, is 8.7 times 10 to the negative 4 teslas. So figure out what this ratio is, take the inverse sine, and we see in the end that the angle that this electron is traveling with respect to the magnetic field is about 19.7 degrees. And that is our answer.